Hey, look, folks, we're going to be talking about circles. And I thought, well, let me look up some things that I'm interested in. I like messing with cars, and circles are seen in a ton of different places in cars, from obviously the wheels, the rims, but also a lot of internal parts, the brake rotors that you can't see maybe behind the rims. I saw gears. Where did those go? Oh, shoot, this may be a different image that I'm looking at, but you can see pistons here. Bearings over here. I think there were some pictures of bearings in here and all that kind of stuff. I mean, everything is circular. The spark plugs. And then I thought, well, I like to shoot my bow. You can see there's a wheel on the bow, and then there's a cam on some bows. Sometimes bows have two cams. They're kind of oblong or squished circles. I like to shoot my rifles, and almost everything when you're in shooting sports has circles involved: shotgun shells, rifle cartridges, all that kind of stuff. In sports, everything that is athletic involves circles. And you might think, no, it doesn't. This guy, Usain Bolt running in a straight line, but his hand is moving in a partial circle, in an arc is what it's called. All kinds of stuff. You can see this guy's helmet here, circular, the shape of the playing balls and everything like that, basketballs, tennis balls, everything is circular in our life, and or involves circles. And so it's important that we have solid definitions for all the vocabulary. The first 8 problems, after you're done watching this video and setting up your notes, I want you to do the first 8 problems in homework. And it just has to deal with vocabulary that you might be able to do, without even taking notes or anything like that. But I still want you to set up some formal notes. So these are the vocabulary words that we're going to focus on. We have a circle, right? This is the circle, right? This is not a part of the circle out here. That's outside the circle, obviously. This is not part of the circle. That's inside the circle. I mean, sometimes when I've got a point inside a circle, somebody will say, hey, that's on the circle. No, 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 no. In order to be on the circle, the object needs to be right on the curved surface, right? Like, so if I put this little asterisk over here, if I put that on the circle, now we're on the circle, right? I know that sounds crazy, like who thinks like that, but or sometimes people will think the center of the circle is the circle. No, if A was on the circle, on the curved part, that's the circle. This is inside the circle, but that is the center. Okay, so let's call A the center, and they'll always use a capital letter. Okay, so circle, let's put a point out here like B. Okay, so B is on the circle. B is on circle. All right. And it's not itself the circle. It's just a point that's on the circle out here. A is at the center of the circle. If I connect A to B with a straight segment, obviously we have a radius. So let me go over to my little segment tool here. And if I drew in that distance right there, that length, that's called the radius, right? If I double that, I have a diameter. So let me make a diameter in here going like, hopefully I can draw this accurately here. That's the diameter. Okay, so please start labeling all of this stuff on your notes. This segment that I just drew is also called a chord. It's also called a chord. A diameter is a chord. But, let me draw another chord in here, because it doesn't have to be the diameter to be a chord. So it could be any segment, and the segment has its endpoints on the circle. That is called a chord. All right, so I just kind of drew a random chord over here, but the diameter is also a chord. Okay, so let me put that in my notes. Also a chord. All right, and that's part of your homework today. It's going to ask you for a chord. So the diameter has its endpoints on the circle. I don't know if you want to add that. Endpoints on circle and going through center. And going through the center. I'm going to abbreviate through center. Okay. And a chord is just the endpoints on the circle. Endpoints on circle. Okay, so let's add some letters in here. Let's see, we're at C, I think, in the alphabet. So C, D, so chord, okay, the diameter is CD, segment CD. We said the radius was segment AB. Okay, so let's put AB. Man, I hope I don't make any mistakes here. That'd be kind of embarrassing. And then let's see, we're at D, E, F. Okay, so we got like just a generic chord at EF, just some random chord. Pi, man, we all know pi is about 3.14. So I'm going to put equals with a little dot over the top approximating it, 3.14, okay? But let's just look for just a second. Where the heck does pi come from? Okay, oops, I didn't mean to hit that button. So I went over to GeoGebra. I've seen some of you guys using GeoGebra, which is fantastic. And I don't want you to really see the algebra right now, but I drew a circle on here. And I don't know, I put the center over here. Oh, hopefully it doesn't move craziness, but I don't know. I just put it at 0.5, 0.5. And then I went down here and said, there's my diameter. Now I could move that, right? So I could just grab my move tool and I could move the radius, right? I can move the point here to change the radius. So right now the radius is 2.5, right? I'm going between A and B. Now my letters might be a little different. Let me see if my letters are different than my notes. No, I got A, B for that. Okay, good. So what would be the diameter? Well, the diameter would be twice this, right? Because a diameter is 2 radiuses. Here's a radius. Here's a radius over here, right? It's 2 radiuses. So pi, let's notice something here. If I go over to algebra and I do the circumference divided by 2 radiuses, remember the distance from A to B is a radius, I get 3.14. The circumference divided by the diameter is pi. Okay, now if I move this, I change this around, notice this 3.14 is not changing. The circumference divided by the diameter is pi. That's what they figured out probably thousands of years ago. So this is a really important relationship, and I want you to put that down right in here. Pi is equal to the circumference divided by the diameter, okay? So we could say the circumference then, if I multiply both sides by diameter, the circumference is equal to pi times the diameter. It's 3.14 approximately times bigger. The circumference is about 3 times bigger than the diameter, or 3.14 times the diameter would give you the circumference, right? So I want you to stop right here. I want you to try the first 8 problems. See if you have enough information to nail those down. And then if you feel totally comfortable going on in the homework, keep going, but come back to the notes when you get a little stuck. I'm going to try to finish off some stuff with circumference and talk about concentric and maybe do an example or two in my video too. Thanks for watching video 1 and taking notes.